Measures of central tendency. We all know that measures of central tendency gives very important characteristics of data. In this lesson, we will discuss regarding averages, arithmetic mean, median, and mode. After going through this presentation, you should be able to explain the meaning and concept of the arithmetic mean, describe median, define mode, analyze positional measures, and discuss the relationship between mean, mode, and median. Commonly used measures of central tendency are mean, median, and mode. Measures of central tendency presents huge mass of data in a summarized form, which facilitates comparison between similar variables and helps in decision making. The mean of some data is the average score or value, such as the average age of an MPA student or average weight of professors that like to eat donuts. Calculation: add all of the individual values and then divide the sum by the number of individual values. Inferential mean of a sample x equals to sum of x divided by n. Mean of a population mu equals to sum of x divided by n. The main problem associated with the mean value of some data is that it is sensitive to extreme values. Example: suppose there are 3 students and their weight is 60, 40 and 45. Then mean can be calculated by the sum of all weight given divided by the number of weight given. That is, 60 plus 40 plus 50 equals to 150. 150 divided by 3 equals to 50. Therefore, mean is 50. The sum of squared deviations of scores from their mean is lower than their squared deviations from any other number. For normal distribution, the mean is the most efficient and therefore the least subject to sample fluctuations of all measures of central tendency. In this example, data of new customer recruited last month is given. Now we have to calculate mean. First, add all the numbers of new customer recruited, which is equal to 211. After that, divide 211 by number of agents given in the data, which is 10. Mean equals to 21.1. It represents the reasonable as a typical or middle new customers recruited. Mean is a reasonable measure of central tendency. The median is sometimes useful and more accurate. The median is simply the middle value among some scores of a variable. Median of a distribution is that value of the variate such that at least half of the observations are less than or equal to it, and at least half of the observations are greater than or equal to it. For calculation, first put the individual values in numerical order, small to large, and then count the number of values in the data set. If odd number, then median is middle value, and if even number, then median is halfway between the two middle values. Median equals to n plus 1 divided by second data value. In this slide, 2 examples are given. The first example has 7 pieces of data, which is odd numbers. Then 7 plus 1 equals to 8 divided by 2 equals to fourth data value. Fourth data value is 30. Therefore, median equals to 30 years of age. Second example has 8 pieces of data, which is even number. 2 middle values equals to 7 and 9. Then calculate the average of 7 and 9 equals to 7 plus 9 divided by 2 equals to 8. Therefore, median equals to 8 minutes. Any value which occurs more frequently than the others, most appropriate when numerical values in a data set are labels for categories, or nominal. Mode is that value of the variate which occurs maximum number of times in a distribution and around which other items are densely distributed. For calculation, First, put the individual values in numerical order from small to large. Then, note the value which occurs most frequently is equal to mode. In example 1, 9 is the value which occurs most frequently. Therefore, mode equals to 9. In example 2, 8 and 15 is the value that occurs the most frequently. Therefore, mode equals to 8 and 15. This example has two modes, so it is called as bimodal. The values of a variable that divides a distribution into four equal parts are called quartiles. Since three values are needed to divide a distribution into four parts, there are three quartiles, viz. Q1, Q2 and Q3, known as the first, second and third quartile respectively. Deciles divide a distribution into 10 equal parts, and there are in all 9 deciles denoted as D1, D2 and D9 respectively. Percentiles divide a distribution into 100 equal parts, and there are in all 99 percentiles denoted as P1, P2 till P25 till P40 till P60 till P99 respectively. If we know the median, then we can go up or down and rank the data as being above or below certain thresholds. There are three relationships between mean, median and mode. First is mean, median and mode. All three are equal. It means it is symmetrical distribution. Second is mode is less than median is less than mean. This relationship occurs when skewness is positive. Third is mode is greater than median is greater than mean. This relationship occurs when skewness is negative. Now let us check if we have understood the various concepts discussed in this lesson clearly. The sum of squares of deviations from mean is minimum. Right or wrong? Right. With continuous data, the median is the most appropriate measure of central tendency. Right or wrong? Wrong. Given a normally distributed continuous variable, the best measure of central tendency is mean. Right or wrong? Right. Before we end, let us briefly revise what we have studied till so far. Measures of central tendency give one of the very important characteristics of data. Any one of the various measures of central tendency may be chosen as the most representative or typical measure. The median is generally a more representative measure for open-end distribution and highly skewed distribution. The mode should be used when the most demanded or customary value is needed. When the data are interval or ratio, we can use the mean as a measure of central tendency. Quartiles are those values which divide the distribution into four equal parts.